Assalamualaikum and hi. This video is presented by Group A consisting of me, Rabiatul Adawiyah, Takif, Takris and Ifwan. In this project, we are proposing the design of a renewable energy power plant with a capacity between 100 and 500 megawatts. Our selected energy source is geothermal energy and the plant is expected to produce up to 500 megawatt of electricity. Geothermal energy harnesses heat from beneath the Earth's surface. Hot water or steam is extracted from underground reservoirs and used to spin turbine to generate electricity. This energy source is very reliable because it runs continuously, not depending on weather like solar or wind. It also environmentally friendly, producing minimal greenhouse gas emission. Geothermal power works best in areas with volcanic or tectonic activity, where underground heat is more accessible.
Alright, so I will be presenting about our process flow diagram which models a simplified geothermal power plant system. So, the system begins with the geothermal injection and production well, where the geothermal fluid is extracted from beneath the Earth's surface. This hot fluid is then directed into a turbine. As it passes through, it expands and spins the turbine blades, converting the thermal energy into a mechanical energy. And then, this mechanical energy is used to drive a generator which produces electricity. After passing through the turbine, the working fluid loses their energy and flows to the condenser, where it is cooled down using a cooling water. And then, the cooling water pump circulates the cooling fluid through the cooling water tower, maintaining the system's thermal balance. And then, the cool fluid is then injected back to the earth to sustain the geothermal source. Alright, after all that, we also included an air source and air sink, representing potential environment heat and a valve for a flow regulation. So this project illustrates the basic working principle of a closed-loop geothermal power cycle, showing energy conversion, heat rejection, sustainability in geothermal energy use.
For the calculation, we only calculate for the turbine efficiency. All the data needed was taken from the research paper called Performance Evaluation of Geothermal Power Production using EES. It is a research paper that conducted in Indonesia. From the research paper, they already stated that they pump around 117.5 ton per hour of steam from Earth to generate around 1.2 megawatts. So, in order to match up the flow rate for our output, which is around 400 megawatt, we use scale-up method, which is we scale up the flow rate that given to the flow rate that needed to produce around 500 megawatts of power. We also made two assumptions. The first one is the steam is superheated and the turbine is isentropic. From the research paper, all the data given are complete, so we use directly what is stated in the research paper, such as the pressure and temperature for the inlet of the turbine. The pressure is 2 MPa, while the temperature is 250 degrees Celsius. So, with that data, we used to find the enthalpy and the entropy for the turbine. As we assume the turbine to be isentropic, we know that the entropy for the inlet is equal to the entropy for the outlet, which means it is S1 equal to S2. And we also know that turbine will have a phase change, which is the inlet will be superheated and after it goes out will be a mixture. So we use this formula to find the quality, and after we find the quality, we can find the enthalpy for the outlet. After we find the enthalpy for the outlet, we find the QH with the formula mass time with change of enthalpy, which is the enthalpy inlet minus with the enthalpy outlet. And after we find the QH, we find the efficiency for the turbine. As I stated earlier, we assume two things, which is the inlet is superheated and the turbine is isentropic. However, I forgot to mention that we also assume that the work net out is at the maximum level, which is 500 megawatts. So, to find the efficiency, we divide the work net out with the QH, and we get the efficiency of 0.45.
Hi and Assalamualaikum, my name is Taki. So today I will explain the comparison with our plant and also with two other plants. So in terms of thermal efficiency, we are able to produce 45%, while for GMA is 40% and solar power system is around 23.5%. For capacity, you are able to produce work of more of around 400 megawatt. GMA is around 1400 megawatt. And lastly, for solar is around 600 to 635 watt. Next is for process cycle. Our plant use Rankine cycle, same goes to GMA. This is because Rankine cycle is able to produce high thermal efficiency. Meanwhile, for solar power system, they are not use any thermodynamic cycle. Instead, they are using photovoltaic effect, which is the effect of direct conversion of sunlight energy into electrical energy. Okay, for the fuel source, we use heat from earth. Next, for GMA, they are using bituminous coal. And lastly, for solar power system, they are use sunlight. For alternative fuel option, in the future, we might use sunlight as our secondary source in order to heat up water liquid. In order to heat up our water liquid into superheated vapor. For GMA, they might use subbituminous coal as their alternative option because subbituminous coal is a type of coal that has low sulfur content. And lastly, for the environmental impact, our design are able to reduce emission of CO2 because the steam produced is only water vapor, not carbon dioxide gas. Next, for the GMA, the environmental impact is they can produce cyanosphere, which is a type of fly ash that is used to make cement as an alternative source. So that's all for me. Thank you.